Hey, this is Passy from Passy's World of ICT, and welcome to another programming lesson. This one is on algorithms and pseudocode, and we're going to do some design with algorithms. We're going to write the pseudocode for the design, and then we're even going to build some of the programs using the Visual Basic console. So we're going to write some console programs. This is going to be like a really long lesson, so we'll just let you know that right at the start. We're going to suggest some places where you could pause and take a break, which is a great idea. We'll give you a chance to do some of the programming tasks. And look, algorithms and pseudocode, the first time you do it, it is not going to be easy. We understand you might be new to this. There's a lot to learn. And look, when I first did it, it was hard too. But with programming, it's like anything. You got to put in the time, you got to put in the practice, you got to do programming. Like basketball players like Michael Jordan, Kobe Bryant, they didn't get to the level where they were and get great just by watching a few videos. And it's the same with programming. Like I read about Kobe Bryant when he was playing for the US Olympic team, and what he did was like he was up at 5 a.m. or something practicing shots in the gym, and then the team came for their morning practice session. He did that with them, and then they went off for a while, but he stayed there practicing shots because he didn't want to let the USA Olympic team down. And that's the determination and what you have to do, and you're going to have to write a lot of programs and do a lot of practice. You just can't watch a few videos. And this video on algorithms and pseudocode, yeah, look, it's probably going to be difficult. Programming isn't easy to learn. But so you might have to watch this video more than once to get the ideas and go off and do some practice with algorithms as well. So look, it's not easy, but I can tell you that programming has been great to me. I mean, I've had a great life from learning programming. It was really hard to learn, but once I learned it, I was good to go. I've worked in the software industry. I've made good coin. I've been on great trips all around the world. I've lived in fantastic places, all because I did IT. So look, short-term pain, long-term gain, but that's enough from me. It's not all about me. It's about learning this. So let's get started. Okay, so some real life algorithms, like there's PageRank. So Google search engine, they come up with a really great set of algorithms, and that's how they became #1. Weather forecasting uses a lot of algorithms from lots of data that they've gathered. This is a very famous algorithm right here. I can't pronounce the name, but that's the shortest path in a network. And if you want to look at the top 10 algorithms, there is a link there for you to go and look at them. All right, our first algorithm we're going to look at is a simple one for brushing your teeth, something that everyone's familiar with, and it's a sequence of processes we do one after each other to get the job completed, which is often what a computer program is doing. So we get our toothbrush, we put the toothpaste on, we clean our teeth one by one, sort of brushing across them, rinse out at the end, rinse the toothbrush and put it away. Okay, you can program a robot to brush teeth. It doesn't work great, but Simone Gertz makes these amazing robots, and she's got a YouTube channel. And yeah, we'll have a look at her brushing the teeth robot because it's quite interesting and good fun, as YouTube always is. All right, this video doesn't have any sound. It's got an ad on it too. It doesn't have any sound, but like, look, that's it. And she made that with electronic components and programmed the robot to do it. And we think it's pretty cool. Anyway, back to the serious learning that we're doing. So continuing with our brushing the teeth algorithm, the order that you do the sequence of instructions in is important. So you need to like have your toothpaste on the toothbrush and then brush your teeth. And then you rinse the brush at the end. And it's crucial in programming, the sequencing, the order you do things in can change things dramatically. Like if we changed our cleaning the teeth algorithm and we just started off using the toothbrush straight away like that robot did, and we haven't got any toothpaste on it, and then we decide, oh, we'll put toothpaste on now and just rinse it all off without ever using the toothpaste, like that's the wrong order, and that's going to mess up your program as well. So we could do this as an iteration, a set of repeated steps. So step 1 is put the toothpaste paste on the toothbrush. So this is if we're trying to design a robot to like do this, okay? And then we use the toothbrush. We've got to clean tooth number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because on average, the average person apparently has 10 teeth across the front there, okay? And then we rinse the toothbrush at the end. Now, if we have a close look at those steps 2 to 11, what we're really doing there is we're doing one tooth, cleaning it, moving along to the next tooth, cleaning it, moving along. So we can write it as repeated steps in an algorithm. So on the right-hand side here, we've got sort of step 1, put the toothpaste on the toothbrush, 2, use toothbrush to clean a tooth, then move on to the next tooth. And we repeat step 2 and 3. So with this little arrow here, we're just showing that you repeat steps 2 and 3. You use the toothbrush, do a tooth, make sure that's clean, move on to the next one, and keep repeating that. But what we need is an iteration. So that's called an iteration in algorithms. So that's a big word you have to learn. And this is a repeat until type algorithm iteration, okay? Now, the only thing is that there is a problem, because at the moment, the way we've written the algorithm is it's just going to keep moving along, and it doesn't know to stop at 10 teeth, okay? So you've got to realize that a computer has no brain, has no eyes. You've got to tell it every single thing to do, just like it was like your 3-year-old niece or someone, all right? You've got to say, don't touch that stove because it'll burn your hand. And you've got to be very detailed in the steps that you give it. So we need some condition so that it can stop doing the repeated steps. Okay, now the condition in this case will be to check if the number of teeth we've cleaned is 10. Once we're up to 10, that's when we want to stop and we want to rinse the brush off. Okay, now this example here, by the way, brushing teeth, this came from the BBC Bite-Size series, I think, on the internet. So they're really good, and we're just using it for education purposes. So I don't think there's a copyright violation here, not in Australia anyway, but let's continue. So we put in this counter at step 5. If the number of teeth cleaned is less than, that arrow means less than, to the left is less than, then go back to step 3. So we keep repeating step 3 and 4 here, moving along, doing a tooth, moving along, doing the next tooth, moving along, until we get up to 10 teeth. And then step 5, it'll see, no, we're not less than 10 anymore, we must be finished. And so it drops down to the next step of step 6 and rinses the toothbrush. So this is classic programming iteration, and this is the way you've kind of got to get your mind thinking to write algorithms and to do programming. Now, most adults have 32 teeth apparently in total, so we should change this algorithm, or we could if we're doing it for real, that step 1, we just set the number of teeth cleaned to 0, and at step 5, we'd check less than 32 rather than less than 10. And that would be the algorithm just there. We only had to change one line, line 5. So once you get these structures, they're good, because if they work for one thing, you can easily sort of copy, paste, and modify them to do another thing. Now, when we write actual program pseudocode, there's a certain way we do it. We don't use sort of spaces between variable names. So you see we've got number underscore of teeth. Now you need to have done our previous lessons. You need to have done the one on data types and how you do naming. And you also will need to have done, at the end of the install Visual Basic, there was a thing about the Hello World program, how to do a basic Hello World forms program in Visual Basic. So later on, we're going to refer back to that. So you kind of need to do our programming course in order. But anyway, this is how you do it in pseudocode. So it looks a bit different than kind of the plain ordinary English written out steps, but that's kind of the way you do it. And you might be thinking, wow, I'll never learn how to do this. This is looking really complicated already. And look, for a beginner, it will look complicated. So don't be hard on yourself. I remember the first time I saw this when I was learning programming, I thought, oh, wow, this is really complicated. But you just get used to it and it's okay. So we have a repeat until is the sort of loop there. So we've kind of put an arrow there to show you that we're repeating these steps inside the repeat until all right, until we get to the number of teeth cleaned equals 32, all right? Then it knows to stop doing the repeats and it goes down to the next line or the next thing in the process, which is rinsing the toothbrush. So repeating something like this, repeat until, that's a classic kind of iteration that we write in pseudocode. Okay, now here's another algorithm. This one's for breakfast cereal. All right, so now there's an issue on this algorithm and it's kind of at the second step. So you've got to think now, if I had a robot doing this, remember a robot can't see, it can't think at all, it's got no real world experience. That step of adding the milk, what could be wrong there? Okay, what it could be is that the robot could just keep adding milk, and it overflows from the whole bowl and runs out onto the table. So we don't have a condition there to stop that kind of step. So as well as doing processing steps, you need to think about conditions for when is the step finished, and I need to put some pseudocode in to then stop and move on to the next step. So often when we write algorithms in our pseudocode, we just desk check them, like we have a look at them, like that breakfast cereal one, we have a think about it, and is there anything missing? So this one here is supposed to work out if you're old enough to drive a car. Now, I think in our state in Victoria, the age is actually 16, but here we're assuming that you live somewhere where you have to be like 17 years old to get your learner license and start learning how to drive a car. But we've got, okay, we ask the person, how old are you? We output that onto a screen somewhere. They type in their age, so we use input, user inputs their age. Then we store the user input's age in an age variable in memory inside the computer. The computer then, we tell it to check if the age is greater than 17, we can send out a message to them, output, you're old enough to drive a car. Else, if the age is less than 17, we can output, all right, you're too young to drive a car. Now, there is a fault in this, and can you see what the mistake is or what is actually missing from here? All right, just some entertainment here. There's someone putting on their learner plates going out to drive. Next minute, oh, yeah, that kind of thing happens. Let's not be nasty to people. All right, so the algorithm has, if the age is less than 17, we forgot about what if they're exactly 17. So if they're 17, ready to put on their L's and have those neck minute experiences, we didn't think of those 17-year-olds. So we needed to have another one here, else if their age equals 17, well then they also qualify here for a student discount, okay? So this was similar to the driver test, same algorithm, just a different kind of situation that they were getting on a bus for a bus fare. So we could also do a more compact solution. So rather than have these three checks, three lots of checking, we just can put if age, a less than sign, less than equal, that means less than or equal to 17, then they qualify okay for the student discount. Now, if they're not less than or equal to 17, we don't care how old they are, but they're obviously not in the eligible age range to get a discount. So we have an else here, so else just means otherwise. They're too old for the student discount. So shorter and simpler is better, and that's preferred. And just a couple of things to entertain you. The wheels on the bus go off, 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 off. Yeah, that looks pretty strange, what happened there. And yeah, we've all had that experience. We're waiting for the next bus. Yeah. Okay, so algorithms programs can require a lot of detail. So let's have a look at this algorithm. So this is one where we're just going to spread some butter on bread. And as a human, that is just such a simple thing to do. But remember, your 3-year-old niece-brained, dumb computer that can't see anything, how are you going to tell that to butter a slice of bread if you're programming a robot or something? So we've got to take the lid from the butter tub, you know, put the butter on, do all the stuff to butter the bread. And then you need to think, well, what level of detail do we require? Because if you get that, like that cold butter out of a cold fridge, or maybe it's been frozen, it's not going to spread properly. So one of those steps there isn't going to work. So maybe we need an extra step that if it's really cold butter, then grate your butter with a cheese grater, handy home hint, end if. Okay, so we could have this sort of little exception process along the way here as well. So how detailed do you have to go with an algorithm? It can be really challenging to predict and cater for all the situations. Now, if you miss a situation in your designing and you don't have a complete algorithm and then you build the whole thing, hopefully you should be doing thorough testing after the build. And when you test out your program and get other people to test it as well and get them to type in stuff and try it out, then you should find, anything that you've missed out. So it's very important we thoroughly test at the end of the process after we've built something, as well as kind of desk checking and looking at algorithms and pseudocode, trying to have it the design as best as we can. Often there's assumptions made. So this is a process for if you just got a standard fixed phone in your house, calling someone up. But we're assuming there that the phone's actually working, and the phone, when you lift it up, has a dial tone. And what about deaf and mute people? So there's all these things. So programming often works on Pareto's principle, the 80-20 rule. And what happens is that getting that last 20% done, that's going to handle all the possibilities and take care of everything, that can take you 80% of the time. So often we write our sort of algorithm for something, we get the program working, it's all good, but then what happens if they type in the letter P instead of typing in a number, right? Because remember, the people could do anything on the program and the computer has no brain to tell them, hey, you're stupid, you were supposed to type a number in there. So yeah, that'll crash the program. So you have to do this thing called validation, which we'll talk about later. And it takes a lot of work. So often with startups now, they have a thing called MVP, which isn't most valuable player like Kobe Bryant and Michael Jordan that we were talking about earlier, but it's called a minimum viable product, so MVP. So they'll build an app and kind of test it, and they know it's like 80% okay, but then they just release it and see how it goes. Now, if a lot of people are downloading it and using it and it looks like it's going to be a winner, they then spend the extra 80% getting that last 20% right. So they'll take it back in the workshop, the programming workshop, fix it all up so it's perfect and it looks really nice as well, really good to use. And then they can release it and sell it and make money. But if they put it out as an MVP, 80% done, and it's not getting used, well, that's not an idea or a product that's going to fly, so they can just abandon that. Later on in our programming course, we'll be getting to algorithms like this, the bubble sort. So this is probably one of the more complicated things we're going to do. And at the moment, it'll probably, you look at that and go, oh, I don't want to be a programmer ever. Like the first time you get blisters on your feet from running around playing a lot of basketball, you might not like it. But remember, no pain, no gain. So we will be getting onto that in the programming course, and we thought we'd show it there just to scare you. Now, we don't want to scare you off, but we will work our way up to be able to do something like that eventually. All right, now the top 10 conventions for pseudocode. So we have program structures. So we've seen the sort of repeat until structure. We've seen if something is true, we need to do one thing, otherwise we need to go do the other thing. So these are called programming structures, and they come into our pseudocode, and there's sort of 10 of them that we need to learn. So at the moment, looking at this slide, you probably won't understand any of it. It's kind of like we're giving you a whole bunch of German vocabulary or something, then we're going to teach you how to speak German. So this is just sort of some structures. So we always have a start at the beginning and a stop right at the end, or you can use begin and end, all right? So that's for right up the top of your pseudocode and right down the bottom, kind of like the front cover of the book and the back cover of the book. All right, now the simplest kind of programming is just where things are done in a sequence, okay? So just if we want to like get the milk out of the fridge, pour the milk into the glass, put the milk back, all right? So there's sort of just 3 steps. Or if we're just adding a couple of numbers together, get the number, first one, get the second number, add them together and show the answer. So there's just sort of steps one after each other. Now there could be if conditions, so we might need, when they put in those numbers to get added up, if the number is negative, perhaps you want to tell them, no, this program only does positive numbers, all right? So something like that. So we can have ifs and end ifs. We can have an if an else and an end if, as we saw with that age of people for learner driving or for getting cheap bus fares. And we can have a case statement. So sometimes instead of if, else, end if structure, we can use this thing called case. We're going to look at some examples of that. So look, this is the first 5. You'll be looking at them going, wow, dude, I don't understand any of this. And that's absolutely fine. Like, we don't expect you to understand this first time around. I know I didn't, and I understand you're going to be having a lot of difficulty with this. It's going to be a long video. We're going to try and explain everything over and over step by step so that you get it. All right, number 6. So when you set something, like we might want to set the number of teeth to 32 before we begin the toothbrushing process. So you don't actually say count equals 32, although that's the way you code it in Visual Basic. In pseudocode, you use this backward arrow, okay, which is a little bit painful for when you're typing it in a Word doc and that. You need to make a backward arrow symbol or get one off Google Images and insert image to do it. But yeah, like we use the backward arrow, that assigns values to variables. But when we're checking variables, like if we want to check if the number is up to 32, we use an equal sign. So the equal sign's only supposed to be used for checking, and in pseudocode you use the backward arrow, okay, for setting things. And we'll see some of that in some of the programming languages. Later on we'll do Python, and we'll see that the backward arrow in Python translates to a double equals, and whereas the backward arrow in Visual Basic translates to an equals, but in the pseudocode it's used as a backward arrow. Only things you'll learn from just experience. Don't worry about it too much at this stage. Okay, there's other sort of conventions there that we can process things, we can display them, we can increment, make something, increase the count, we can do our mathematical sort of operations there, and you can have your not equal to, or greater than, less than, equal to signs. Now, if you want to repeat things, do that iteration that we were talking about, you can use these for loops. So a for next loop, that's a programming structure which we're going to have a look at and write a program in Visual Basic to demonstrate that. So for next is something you need to learn for your programming structures, your sequencing structures, so that you will be able to write pseudocode. And there is repeat until. Now, repeat until can be dangerous in some situations to use, so we're going to talk about that. That doesn't mean don't use it at all, but there is some issues with it in some situations. The while condition is kind of better to use than repeat until. So while, you know, we've got less than 32 teeth, keep brushing one and moving along, brushing one, moving along sort of thing. So that's one that we use for repeating. So these are the 10 commandments of pseudocode, people. So after you've learned pseudocode, you'll sort of go, oh yeah, I know all those 10 things. Right now, they're seeming like the 10 most complicated things you've ever done in your life. But it won't be like that once you do some practice, okay? And just a little funny there for the Catholics or anyone else. So Moses was the first person to download files from the cloud using 2 tablets he actually used. Maybe had an Android and an iPad. All right, so here's a break for you. Just pick one of these processes here and try and think of what would be the step-by-step if you needed to do one of these, okay? And just pause the video now and try that out, see if you can write an algorithm, and then we'll come back and continue the presentation. All right, so we've covered sort of the basics of things, and already you might be thinking, feeling very overwhelmed that, wow, this is really complicated. What are we doing here? Third, I think this is, you know, an early lesson in the programming course, and already it's getting so complicated and hard. But look, just hang in there, okay? And have a go. See this through the end. Maybe you'll need to watch it again. Look, it can be done, all right? I remember when I did it, and I understand, like, this is really hard because it's all brand new and totally different to anything else we do in our daily lives, all right? So sequence, let's have a look at sequence. So sequence, we could have something to add a couple of numbers together. So we could tell the person, first we begin the process here, then our pseudocode is that we want to print out or output onto the screen. I think I was supposed to write output. I think I've broken a commandment already. So print out, please enter a first number, and then we read number A means that they'll be able to type the number in, and then we'll ask them for the second number with a print, then read number B means they can type the number in, and the answer will be created by adding those two numbers together, and then we need to output that answer or print that answer out onto the screen so that our user can see that answer. Okay, so let's have a go at writing this program in Visual Basic in Visual Studio. All right, so we're going to do that. Okay, here we are in Visual Studio 2017. So you may not have done a console program before, so we're just going to do our usual file, new project here. And when the projects come up on Visual Basic, so we're going to be on Visual Basic, and we're just going to do Windows Desktop. Now on Windows Desktop, see this third one down, Console App? Okay, so we're going to do that, the Console App. So previously we did a Windows Forms app when we did the Hello World program in our course. Now we're going to try a Console App. So we just do Console App, and here we're going to give it a name. So we'll call it, we'll just call it a console so we know it's a console, and let's say call it adding numbers. Okay, and then we just say okay, and that's going to open up just a coding screen. We won't have a form screen here. We've just got some coding, and we're coding a module, and we're going to have one subroutine for it. Okay, so the first thing we need to do is to actually dimension some variables in Visual Basic. So we have to tell Visual Basic that we're going to need some variables for this program. So we're just going to have them as type doubles. So we're going to have DBL first number, and we're going to dimension that as a double. So remember, a double is something, you need to have watched our kind of data types and naming, that a double means we'll be able to put a decimal value in, and then we'll put that it's equal to 0, okay? Then we need to dimension two more, so let's kind of just color that in with the mouse and do Control C, and then if we just do Control V and another one Control V to save a bit of time. So we're going to need a second number. So we're setting up the memory here. So we're setting up memory locations where the program can store things which have been typed in or have been processed and calculated. So we'll just DBL the answer here to define the answer as well. Okay, so that's just setting up three memory locations where we're going to store what the people have put in and what our answer works out as. Okay, so, all right, now we're going to use console write line. So we just start typing console, and then you do write line. Okay, and we're just going to do equals, and then you open up quotes, and this is just going to be like the heading up the top of the program. So we're just going to call this the add numbers program. So that's just going to put a heading at the top of our page, and it's squiggling and underlining that. I'm not sure why it's doing that, because I think it looks okay, Visual Basic, so it's not liking that. Console write line. Okay. Let's try it again. So, and then underneath that, we need to have like a blank line. So we're just going to go console, write line, and we're going to have brackets. Okay, now, why do we have this squiggle here? It's because I've used an equal sign. Okay, so my pseudocode might say output equals, but it didn't even say that. But we actually need to just sort of follow the pseudocode. The pseudocode said, if it says output something and then the thing, we just need console write line and the thing. You don't have to put an equal sign in, okay? So that's just a beginner's mistake that's easy to make. Now we need some instructions to them to enter the number. So we need console write line again. So console dot write line. I don't know whether you can make a hotkey to just do console write line, but we need to tell them enter your first number. My typing's really slow because I don't usually do things on this laptop keyboard, do it on the big computer. And then we need to do a console read line. So what a read line does is that will stop the program, and that's the input. So this will stop it and someone can enter their number. So we'll just have console read line to get their number. Now, where we want that number to go is we want that to go into the DBL first number that we made. So we're using an equals here. So what we've done is console read line will stop the program so it can get some input. That's sort of your input statement in Visual Basic in a console program. And DBL first number, that's where we want to store the input. So we set up that storage originally. Let's just run the program at this stage and we'll show you what it does. So if we press this start up the top, it'll just take a little while because it's building a whole lot of folders and building the whole project. So that's why it takes a while. So you can see here, it's done the things we needed it to. If we can move that, we can see. Okay, so this stuff, the dimensions, they happen behind the scenes and we don't even see them on the output screen here. Nothing's happening. That's all inside the computer in the memory. But the console write line, add numbers program, that's what's put that nice little heading there. And then we've got console write line, enter your number. So it's printed that out from the write line and then it's stopped and it's doing a read line. And if I put in 5, or because I've used double, I can actually put in decimals like 5.2 if I wanted to, and press enter, that number will go into memory and the computer will remember what it is, okay? Now I pressed enter there and the whole thing closed down. So at the end of your program, you always need a blank console read line to do that, to stop it from happening, but we'll see that in a minute. So look, the next thing is just entering another number. So you can just pretty much copy and paste this code here. And here we want to say enter your second number. And we need a console read line to stop the computer and read that in so they can type it in. And this one here is the DBL. And see, the helper here has found our variables for us. So we can just double click DBL second number and that goes in there. So that's going to get our second number. And then we're ready to go and add them up. So we'll just do another console write line and I'll just copy paste here, Control C from there and Control V down here. We need another console write line, just to leave a blank line before we put out the answer. It looks nicer on the screen. And now we're going to add the numbers together. So remember we set up DBL answer number. So DBL answer number is where the answer goes. And we just do mathematics now. We just write DBL, not DL, DBL, and we get our first number and we use the plus symbol and we use DBL and grab our second number. Just a word on these things. So if we wanted to subtract them, we could use the minus symbol on the keyboard. But for multiplication, you use the star symbol. That means multiply in most programming languages, including Visual Basic. And if you wanted to divide the numbers, you'd have to use the slash key, okay? There's no timesing and dividing symbols like there are on a regular calculator on your keyboard. So we have to use star and divide. Right, so let's just run this and see where we're up to. So it should be able to get both of their input numbers. So we put in our first input, our second input. It didn't calculate anything. It didn't show us anything. Okay, we need a console, always at the bottom of your program, you need a console read line. So the computer will stop. Have a look at this. So what's going to happen is we've put in our numbers. But see how it's stopped there and it's flashing and it's waiting for an input? That just kind of stops the console so you can actually see what happened on your screen, okay? If you don't have a console read line at the end, it just closes itself up and finishes. So we need that. Now, we're not seeing our answer, and the reason is because we haven't done a console write line. So we need a console write line to put that out onto the screen. So we're doing console dot write line, and here we're going to put in, now remember, don't do the equal sign, you just have to do console write line brackets, and we've got here the, we'll say the sum of your two numbers is, space, close the quotes. Now, how do we get the number answer out? Okay, so we can tell them the sum of your two numbers is, that's going to print that little sentence on the screen. Now, the answer's sitting in DBL answer number that we dimensioned up the top here. So you just use the and sign, not the plus sign, because that's used only for mathematics. But we use the and sign and we say we want to add on and show DBL answer number. Okay, so don't be scared that that looks complicated. We're just printing out that, and at the end of that sentence, we want to add on what the actual value of the DBL answer number is in computer memory. So fingers crossed, this should be finished and it should all work now. So if we put in our number is 2 and our number is 3, we know that should be 5. The sum of your two numbers is 5. So that's working nicely. It's got the console read line at the end to stop it so we can have a little look at it. This box here, by the way, if you're fussy about all the wasted real estate, you can shrink that down like that. And we can just press enter and then the console will close itself. Okay, just run it one more time because we did set these up as doubles so that we could use decimals. So let's say we were doing 1.5 and we were doing 1.21, which should give us 2.71, and it does, okay? So that's all working with decimals as well. Maybe one more test, so we should always give our program testing. Will it work with negative numbers? Like if I minus 3, if I take $3 from you and then the next day I say, hey, can I borrow another $2 from you? Well, then now I should owe you $5 and it does come out -5. So look, it's pretty good. And that's finished. So that's an example of how to write a Visual Basic Console program. So we will have some examples in the algorithms that are coming up where you get to write some console programs. So this is showing you the steps. And of course you need to do your save all. So we want to save this fabulous program we've made. So let's just do that. File, save all. Now we need a location. Now I think I've already set it up. Just browse to it. So this is in programming, algorithms, pseudocode. Yep, put it with all those other programs I've done. So I select that folder and I've got a good name for it, adding numbers console. And I can just save that and it'll save into that folder. Okay, now it's a little bit slow there saving, but that's all good. So we're done. All right, take a break now if you want to. Maybe have a go at writing that program, and then we'll be back to look at more on algorithms and pseudocode. Okay, so that was our first Visual Basic Console program to add up two numbers, and here it is if you need to look at it, if you're going to try that out yourself to do. And let's move along. That was sequence. That was our first structure out of the 10. All right, now the next one is having an if-then condition in there. So this is sort of stopping to check for something while you're doing your processing steps. So for this example, we want to use it to type in a number between 1 and 10. Okay, so if the number's bigger than 10, we want to give them an error message and tell them that, yeah, that number shouldn't be bigger than 10. So if they type in 15, we want to say, hey, your number should be between 1 and 10. So like telling the little niece, hey, don't go play there, that's dangerous, and so on, because the computer has no brain, remember. E.g., do validation. We call this validation of input data. So our pseudocode will look like this. We'll have an input, or we've written an output, sorry, onto the screen. So you could say output there, please enter a number, read number, so that's like a console read line that's going to get the number typed in. Then we do some checking. If the number's greater than 10, please enter a number less than 10. All right, so we're just going to put out that message to them and stop there at the end. So we're using start at the beginning, stop at the end. Okay, now there's still a problem with this because they could enter some negative numbers like -3 or -6 because we just entered negative numbers when we tested out our adding console program, and you can put them in and that can happen. So maybe we need to give them more information, and they could also enter 0 for their number. Now you're thinking, oh, well, they must be stupid because we told them to type in numbers between 1 and 10. How stupid are they? All right, there's all sorts of people in this world like Homer Simpson types, and we need to do that, okay? So we need to do validation to make it bulletproof, so we should also include this. So how could we do that? How can we tell them that sort of 1 and 10 are both unacceptable if they're outside of that range? Well, we could do with an or statement. Where we had if number greater than 10, we could just add on or if the number's less than 1, well then it's not between 1 and 10. So you might need to think about that. So if it's greater than 10, it could be like 12, 13, 246. If it's less than 1, it could be 0 or negative numbers. So we tell them, nope, they're not the ones we want. Please enter a value between 1 to 10. Now you can also use it with if else. So we have if the number's greater than 10. So that's the first thing we check for. So numbers like 12 and 25 would come up and the message would be please enter a number less than 10. Now if the number's not bigger than 10, it might be okay. It might be the number 4 that's good. So let's do an otherwise here and just do a check now. Let's just make sure it's not less than 1, that it's not a 0 or negative number. If it is, if that's true, if the number's less than 1, we're going to send out that message, please enter a value from 1 to 10. We have to have end ifs after our ifs. So we have if end if on this guy and we have if end if on that one. Okay, so look, that's a bit complicated, but try and just remember sort of front covers and back covers. We have the front of something and the back of something. That's your if and your end if. Okay, now there is a case statement you can use rather than if else. So if we were sorting out these color blocks, we could say, hey, great, if it's red, put it in the red tub. Else, let's check if it's blue, and if it's blue, put it in the blue tub. Else, let's check if it's green. If it's green, green tub. Otherwise, if it wasn't red, green, or blue, it must be one of those yellow blocks, so that goes in the yellow tub. Okay, now that'll be a long if-else. Case can be a sort of more compact, simpler way of doing that that's easier to read as well. So you can use a case statement like this. The first part could be written either of those two ways. But while the number of blocks is greater than 0, so we need to tell the computer to only keep doing this while it's got blocks still left to process. Otherwise, the silly computer with no brain will just sit there doing it forever and ever, which is called an infinite loop. But yeah, if it's red, place it in the red position. If it's green, put it in the green position or the green tub container, and so on. So case end case can be a lot neater than writing if else. And we'll show you some case end case later on. Right now, in fact. So we've got case here and end case. So we have a check out some variable, and if it's a particular value, do this thing. If it's the other value, do the other thing. And we want the user to type in that number to 1 to 10. So remember, we were doing that with if else. Numbers greater than 10 or less than 1 are unacceptable. So we don't want zeros or negatives or numbers bigger than 10. And if they type in a value between 1 and 10, let's congratulate them because they've done a good job. So this is how the pseudocode for the case statement would be. So same thing as usual, start, enter your number, read the number. If the value is greater than 10, so case of numbers, so we're looking at this number variable that they put in. So if it's greater than 10, enter a number less than 10. If it's less than 1, hey, do something between 1 and 10. If it's actually between 1 and 10, which looks very complicated here, but that is how you tell a computer if the value is greater than or equal to 1 and it's also less than or equal to 10, well, you're good to go. So congratulate them and tell them excellent choice. So that can be a much easier way sometimes rather than doing a whole bunch of if-else statements using the case statement like that. Okay, now we want to do a number between 1 and 10, and we don't want them bigger than 10 or less than 0. For 1 and 10, we're going to congratulate them. So let's have a look at this. That was the case version that we did. Let's have a look at how you do that with if else. So you'd start, get them to put in the number in, and then we check, is the number 10? If it's bigger than 10, well, that's no good. Please enter a number less than 10. If it's not bigger than 10, let's keep going with the checking. So we go else. We better do that other check that it's not 0 or negative. If it is, give them a message. But if that check doesn't come up, the message won't happen. And so we say, okay, we've checked for bigger than 10, we've checked for negative numbers, it must be good to go. So you do excellent choice. So you can assume here, if it's not too big and it's not too small, it's just right. And so there you go, you can give them the message, excellent choice. Kind of a bit like that Goldilocks and the Three Bears story. There was the one that was really little, the one that was too big, and then there was the one that was just right. Okay, so if you've worked out it's not too big, it's not too small, well then by the process of elimination, you can say yep, I've got the right one. You don't have to do another if statement saying if number, less than or equal to 10 and greater than or equal to 1. We can just do it by the process of elimination and make the code more compact and simpler. Okay, so that's something you might have to think about. It was hard, I remember when I started to get my head around that, the sort of else at the end, which means none of the other things got done, so we're here at the end of the process and things must be good. All right, let's expand out now into a number guessing game. Okay, and how we do the algorithm for that. So we want the user to guess a number between 1 and 10. So this time they're not typing it in, the computer's going to have this number that's between 1 and 10, and they're going to type in a guess to see if they can guess that number. So we're not going to check the user inputs. If they're silly enough to put in 25 for their guess, and we told them, hey, the number's between 1 and 10, we're not going to worry about that. And if they're silly enough to do a Homer Simpson and type in negative numbers, oh, what's this button do? I might type in -5 for my guess. We don't care. We told them it was 1 to 10, and if they want to do something else, well, they're never going to win the game, and that's their problem, because it's not going to crash the computer in this game, so not crash the program, so don't have to worry about it. We'll congratulate them if they guess the number. We'll tell them if their guess was too low. We'll tell them if the guess was too high. They only get one chance to guess the number, and that's it in this game. So the algorithm will be like this. We're just going to set the number equal to 7. That's the lucky number. That's sort of the mystery number is 7. So they can enter a guess in the range of 1 to 10. We have a read, so they can type that in. Now, if the number they guessed is bigger than the answer, we just say, sorry, your guess was too high. If their number is too small, if it's smaller than the answer we've got, so if it's smaller than what we've set up there is 7, it was too low. And if it's not too high and it's too low, well, wow, they must have guessed the number then. So we'll say, message, great work, you guessed it. And that's kind of the algorithm that we're using. Now, in the real version, maybe we should have validation, because if they type in actually the letter P or an @ sign, that's actually going to crash the program. But look, for this simple case, we're not worrying about having the validation, because we're going to write the Visual Basic Visual Studio program. Just a little challenge for you if you wanted to do this sometime, or pause the video and try it now. Write a case version of this algorithm and see if you can do that. Okay, so there's our pseudocode for our guessing number game. So pseudocode's great because you don't have to worry about whether you've done your console write line equals brackets wrong like I did, or whether it should not have the equal sign. You're just writing pseudocode. So this sort of gives you the plan of how to do it, all right? This is sort of the high-level plan. We just got it written out there kind of in English that kind of makes sense, and now we need to put that into some code. So a Visual Basic form app, kind of like the Hello World program we did back when we did the Install Visual Studio video, would look like this, that we'd have to dimension some values in the computer's memory, like what the answer is, and set that equal to 7. We're going to use integer because this is whole numbers between 1 and 10 we're talking about. We're going to have a space in memory where we can store their user's guess. So that's going to be called int user guess because it's an integer. And then when they click the button here, the button's going to be called BTN Go, that Go button. So when they click BTN Go, that's what this subroutine here is. It handles a click of BTN Go. So they click this button. First they type in their guess. So the guess was 5, let's say. They put that in the text box there, and that's called text user guess on the form. They click the Go button, and then it'll do this checking. The same checking as we did in the pseudocode. So if int user guess is bigger than the answer, you're too high, otherwise could be too low, or maybe they guess the answer and we can say great work. So when you've got these message boxes, that's how they look. They'll just be a pop-up box, a standard Windows box, click OK, and then the box will close itself. Now, so that they don't keep going back and typing in and clicking the button and having more guesses, we've just got some disabling code here at the end. So text user guess, that's this text box. We just go set its enabled property to false, and the button too, we set the enabled property to false, and that means they can't go back and keep clicking and guessing. They only get one guess. All right, so you may want to pause the video and have a go at writing that video, that program. You'll have to make the form. Go back and watch our Hello World program when that was in the download Visual Studio and do the Hello World program, so that you know how to do like labels. This guessing game thing's a label, this writing here's a label, text box, button, and picture box. And that's just an emoji that we just found on Google Images. So yeah, or you might just want to pause the video and have a break, because we're covering a lot of material here and it's going to be a really super long video, but we're hoping that we're really going to teach you algorithms and pseudocode in this and you'll get a handle on it. And to keep it simple, don't bother about having any validation in there. If they type P or an @ sign in that text box, sure, the program will crash, but let's not worry about that for today's lesson. That's coming up later on when we do validation. All right, so iteration algorithms, we can have while loops, okay? So while and end while, so that we saw that with the brushing the teeth. While we're less than 32 teeth, keep brushing. And the pseudocode to the right is set up to do 10 repeats. So here we've got some pseudocode begin and end at the bottom, and we're setting the count to 1. And while that count remains less than 10, we're going to do some checking. So if the count's smaller than 5, we're going to print out repeats are less than 5. If the count's less than 10, we're going to print out repeats are less than 10. Otherwise, the count must be up to 10 now, so we're going to tell them the count ended at 10. And then as the loop progresses, so sort of count number 1, it comes down and does this once, then we add 1 to count, so count will now be 1 plus another 1 will be 2. So second count, it comes down through here, then it's on count number 2, so it'll add 1 on and get to count number 3. It'll come back up to repeat the loop and it'll say, oh yeah, I'm still less than 10, so I still keep going for number 3, number 4, number 5, number 6. When the count does get up to 10 through this little incrementing, this adding on down the bottom, then when it gets back up the top, it's going to say, hey, I'm equal to 10 now, I know it's time to stop. Okay, so we have this while count and end while. That's the loop, that's the repeated part, and that's going to get repeated 10 times before it stops. So everything in between the while and the end while, that's all repeated. Okay, the output results of it, if you kind of worked it out in your head and traced through it, this is called a trace table, and we'll talk about these another time. But basically you set up what is the count value at the moment, which repeat are we doing, the first repeat, the second repeat through this loop, and what do we expect the output to be. So when we're on count 1, the count's going to be less than 5, so we expect it to print out repeats are less than 5. So it'll print that out for a while, then when the count hits 5, it's not less than 5, it's just repeats are less than 10. When it gets up to 10 at the end there, it should get to this last part and do count ended at 10. So you can pause and have a bit of a think about that and work through it. You could even write a console program in Visual Basic to do it if you had the time and if you want to. But we understand you haven't got a lot of time. That's the other thing, like, sure, Kobe Bryant did all those practice shots and stuff, but he had the time to do it. Most of us don't have the time to sit down for several hours and do something to get perfect at it. So do your best to make time and to practice. So we're going to take our number guessing game now, and we're going to use a while loop so that they get the 3 guesses. So the guessing process, though, will stop if they have actually guessed the number. We don't want to keep going 3 times. If they guess it the second time through, we just want to stop everything. And we only give them 3 guesses. So we're going to have a number guessing game now that's not 1 guess, but they can actually have 3 guesses. So this is a pseudocode. The black writing here is what we had previously. The blue is what we add in to do the while loop. So we'll need some more variables. We need to set the guesses are equal to 0 at the moment, because remember, they're only getting 3 guesses at this, and that the game hasn't finished yet. So the game will finish when they either guess the number or they've used up all of their 3 guesses. So to get started, because we had guesses set to 0, we need to add 1 to the guesses. Okay, so we're in the loop here. We say, ask them to enter their guess. We read that number in, so we stop and let them type in a number, and that's their first guess, so we add 1 to guesses. Then we check, is the guess too high, guess too low? If they've actually guessed it, that's great work. Now, if they have guessed it on guess number 1 or guess number 2 or even guess number 3, we want to put out that message, but we want to set game over equals true, because we want to stop. We don't want to say, hey, ask them for another guess. What's the point? They already guessed it and it's great work and they've won the game. So game over equals true. If they're up to 3 guesses now, we need to check, and that's also game over. So if they've used up all their guesses, that's game over. So the game over can get set to true 2 different ways. And then we end the while. Okay, so the repeated part is between this arrow. The print game over is outside the arrow. So once they've either guessed it or they've had their 3 guesses, we also want to print out game over. So they know, hey, the program hasn't just frozen and stopped. It stopped for a reason, that's because the game's over. So we use a Boolean true false variable. So we have while game over equals false. So we set it to false to begin with, and then when the game is over, we set it to true. So that's a Boolean variable. You would have seen that in our data types video. And the while loop will keep accepting and processing guesses while game over remains false. We can write a VB console program for this, and this is what it'll look like. We'll have a heading, 3 guesses, number guessing game. Enter your first guess, tell them that guess is too low. Because remember, we've just hard-coded in there that a mystery number is 7. Enter your second guess, so they might go higher, they'll go to 8, that's too high, and then maybe they'll think, well, it must be either 6 or 7, and they put in 7, they actually guess it, and then at the end it will give the game over message. Now, if you want to write this console program, this is what you'll need to do. Set up a new console program and write that stuff to start the loop, do all this checking inside the loop. After the loop is finished, when they've had 3 guesses, write the line game over, and that will do your program. Have the console read line at the end, remember to stop it, otherwise it'll close itself down, you won't see anything. And console clear just clears out the console from all the stuff that was in it. It's just a bit of tidy up housekeeping at the end. So pause the video now, you probably need a break anyway, or you might want to actually kind of have a go at writing this console program. Remember, the more programming you do, the better you get. Let's look at the for loop. That's another type of loop for when you want to repeat stuff. So we've got a module here for some pseudocode that was given to us. And what that's going to do is that it's just going to do for the int count is 0 to 5 here. So it's going to go from 0 and up to 5. And each time it's going to say it's in a loop number. So have a look at that. Have a think about it. This is what it actually does. So it'll say I'm in loop number 0, then 1, 2, 3, 4, just goes up to 5 because we set the loop to go from 0 to 5. And pause the video. Or in the YouTube description for the video, you can get a link to the download and download a PDF of this presentation. Write that console program, play around with it, figure out what it does. Check you can get the sort of solution answer shown here. Now we can do a for next version also of that number guessing game. So without trying to confuse you too much, because we did it with the while loop. What are you doing, Passy? Well, let's just do it with a for next loop, just showing you how you could do it with that. Okay, so we define our variables and we set up a for next loop. So what'll happen here is we set up for the number of guesses from 1 to 3, do all this stuff in here. Keep getting a guess off them, checking how the guess is, and then do that 3 times, okay? Because we've set for the number of guesses is 1 to 3. It'll do 1, 2, 3. Now, the thing is, if they guess it on guess number 1 or guess number 2, we need to kind of stop that from repeating. And how we do that is we kind of do a bit of a fudge here. We just set the number of guesses to 3. So if the first time through they get really lucky and guess 7, we just put number of guesses is 3. And what will happen is the loop will get down to the next, and the next automatically moves the counter up, so it'll make int number of guesses up to 4. It comes back up the top and says, yeah, I'm doing this for the guesses between 1 and 3. Hey, the guesses is now 4, so it'll stop. So it's kind of like an emergency stop button. We're kind of faking that by setting the number of guesses all used up to 3. And so that should produce the exact same output when you test it out as the while version did. So often you can write a for next version to solve an algorithm, and you can write a while version. They're both iterations, they both do repeats. As long as they both work, who cares? It doesn't really matter which one you write. It's kind of a matter of personal choice. But you do need to understand how both of them work in case you're reading someone else's program or you're doing an exam question on it. So you can use the do while loop as well. That's an older version of the while end while that we did for our number guessing. So people don't use this one so much anymore, but it will work if you type it into Visual Basic. And if you're watching some old videos on YouTube on how to do things or look up old stuff, it might have do while and loop instead of while and end while. So do while loops though can be a bit dangerous. So let's have a look at that. And Here we've got while count is less than 4, we're just going to print out the number and then we're going to add 1 to the number. So instead of doing count equals count plus 1, you can do this plus equals 1 thing. That means just add another 1 onto it, the plus equals. Anyway, both of these programs should do the same thing when you look at them. And if you do a console program like we did to check them out, they both do give the answers 1, 2, 3 as you'd expect. But there is a danger with this second version of it, with the do while version, and that's what we're going to talk about now, that the while checks the condition right at the start. So if the number's not less than 4, there's no way it's going to go in and do any of that. But if you have a close look at the other one, the do while checks it at the end. So if the number was, say, 4 or 5 or 6, it's still going to do this, and then it's going to do the checking here. So it won't repeat it a second time, but it will do it the first time, and this can be dangerous, okay? So do while, if you've got the checking at the bottom of the loop, that is dangerous. So we'll show you a couple of VBNet programs here. So here's a VB console program where we've got the do while with the checking at the top, and that works fine. That is safe, that gets the big tick, and that will give no output, because if we set dimension here, my loop number as integer, and we set it to 4, well, when it comes down in here, it says, oh, do this when the number's less than 4. Well, no, we've got a 4. That's not less than 4, so I won't do anything. I'll just jump down here and do the console read line and the console write line. But see, with the with the while at the bottom of the loop, if it's 4, it's just going to come in here and do this, and then it'll check, oh, is it less than 4? And so it won't be, so I won't go back and do it a second time, but it will do it once the first time, and this is what's dangerous. And if we had it equal to 5, 6, anything bigger than 4, this would happen. And when you actually run this, you get a 4 output, so you get a different output to that, even though if you just had a quick look at the pseudocode, you'd think they were both the same. So you may need to pause the slide and think about that, but we kind of need to move on because this is a super, super long video. So it's best to use loop code that checks the condition right at the start of the loop. So this is kind of for more experienced programmers. So maybe after you've written a few more programs, done a few more lessons, you might come back to this presentation and you'll go, ah, yeah, that's kind of making sense now. Right now, I could understand that your brain may be totally overloaded, and that's fine. Like if you've taken in some of the things we've talked about so far, that's great, and that's going to help you with your programming. We're just kind of doing the kind of really finer technique points here. So someone has learnt sort of here how to do long jump into a long jump pit athletics, but now we're going through the finer points of, yeah, you really need to sort of count back with your running steps and get your pace and stride and get perfect on the takeoff board. This is kind of all the finer points now. So look, think of the do while loops and that if you check at the start is the best thing. So let's just say we were going to dive into some water in a river or a lake or a pond or even a swimming pool or something. So we want to check the depth of the water before we do that. Because in a while loop, that's how it works when you do checking at the start. You kind of check how deep that is, like poke a stick into the river or something and check it before you dive in. Because if you do the checking after the dive, well, it's too late. You might have already broken your neck and be paralyzed for the rest of your life. And that's horrible for the people that happens to. All right, so do not do the checking at the end of the loop. Look, it can work in some programs, but just remember it's very dangerous. Test thoroughly if you do it. If you want to be a thrill seeker, we're just saying try not to do it that way. There's also repeat until, so do until with a loop at the bottom. If you do the checking up the top, that's all fine. But you know, if you're checking down the bottom, it has the same risks as this kind of the do and then the loop while at the bottom. So just be aware of that. There are repeat until loops as well, and you can code those in Visual Basic, although it's kind of, I think, an old way of doing it. So to finish up, if you are doing the Victorian VCE, the software development, what sort of exam questions could you get at the end of the year on this? So, you know, if you're just watching this to learn programming, you could just stop the video now. But anyway, have a look at this. Here's some exam questions. So we've got A equals 5, B equals 7, C equals 3. This is looking more like some algebra question from a maths test. But which of these variables, which of the functions will return a value of false? So function A, is A bigger than C? Well, is 5 bigger than 3? Yes, it is. Or is B greater than C? Yes, 7's bigger than 3. So that should return a true. That should go to this part of the processing. That'd be true, but we're looking for the one that's false. So function B, if C is less than B, 3 is less than 7, well, that's okay. And A is less than C, 5 is less than 3. No, 5 isn't less than 3, so it won't do this true part. So it won't do this part, and it'll go to the else, and it'll do the false, all right? And so that's actually the answer. The correct answer for that multiple choice is B, because it wouldn't satisfy this if condition. And you know from the pseudocode and learning your 10 commandments there, that it would drop down into the else and come back with a false. So these are just some percentages of all the students that did this exam in 2017. So the correct answer was B, and it looks like sort of for this question 77% of the students got that right. Okay, 5% said it was A, 7D and 11C. Okay, here's question 3. So they might give you a pseudocode kind of algorithm on the exam, and then there's a couple of multiple choice questions here about that algorithm. So we're going to begin, and we're going to type in a score. If that's bigger than 75, we're going to drop into here, and then if it's bigger than 85, we'll tell them it's an A. Otherwise, it's going to be a B. And if you're not bigger than 75 and you're not bigger than or equal to 85, so you haven't got your A or your B, well, then the rest of yous all get a C. So nobody fails. That's nice. I like that algorithm. Right, so the algorithm needs to be tested for logic errors. Which of the sets of data would provide the best test? Okay, now this is a classic question. The thing is, you need to test boundary conditions. The boundary conditions happen on 75, so you need to make sure if it is actually 75, would the boundary work in 85? So the tip is to look for things with 75 and 85 in them, and we'll look at the answer in a minute for that. And the algorithm contains procedures and functions, procedures and instructions, control structures and functions, selection statements. The if else, that's where you're selecting things and deciding, yep, it's bigger than 75, I'm selecting that and I'm going to do this to it. So it's definitely D for that one, okay? So you need to make sure both your 75 and 85 boundary conditions were part of the testing, and that was the only answer that had it, and its selection statement. And there's some percents for you just to see on questions 3 and 4. 41% picked B, so that was actually a hard question. A lot of people didn't get that right. And only 31 selected D. Okay, so remember, if else is a selection statement. Look, the BBC bite size was great for those algorithms about cleaning the teeth. The 10 commandments come from this book by Adrian Jansen, which is the book we use for our VC software development course here in Victoria, Australia. And some of the stuff on the Visual Basic Loops came from the coding guys, so you can check out those links to find out more about that. So look, thanks for watching. That was an awesomely long video. I think it's going to be like just around 1 hour long. So look, hopefully you paused and took breaks in between, and you may have to go back and watch it 2 or 3 times, and definitely try out those console programs to see how the algorithms work, because that will help you out a lot. And you may not believe it now, but kind of, you know, after you've been programming and been through, say, 4 or 5 more lessons even, all of these 10 commandments, the if else, the case, the while, end while, all of that stuff will kind of just make sense and be things you know how to do. It's, you know, it's hard. It's kind of like if you're a kid learning how to do woodwork at the first time, right? You've sort of got an idea of what a hammer does because you've seen people smash things to pieces in a YouTube video. But, you know, using a hammer and a nail to do fine detailed, or hammer and tack to tack something down because it might be too small to use a nail gun on, or to hammer a little hook in the wall to hang up a beautiful picture. And then learning how to use a chisel to sort of cut notches out of wood, how to use a plane, an electric planer to smooth something down really straight, how to cut things and rule them off, and use a circular saw to go straight, or a jigsaw to cut out that round symbol there for the smiley face. They'd all be skills that you'd have to try and practice. And you're not going to just watch one YouTube video, you know, pick up a jigsaw and cut out a perfect circle for a smiley emoticon, right? You're going to have to do it and practice a few times. And you're not just learning how to use one thing, you've got to learn how to use several things. So if you were a carpenter, you'd have to learn how to use a whole lot of power tools and be good at them. If you want to be a programmer, you're going to have to learn how to use if-else. You're going to have to learn how to use case. You're going to have to learn how to use while, end while. You're going to have to learn how to use for next. And it's not going to be easy, but once you've practiced it, it will be easy. Just like a carpenter picks up their tools when they're on a job after they've finished their apprenticeship and they're fully qualified. It's easy. They know what they're doing, and it'll be the same for you with programming. So look, thanks for watching. Stick with it and try hard. I know it is really hard when you get started with programming. It was super hard for me. But if you can do those hard yards and like have a career in IT, it can be one of the best things ever. So enjoy your Visual Basic programming.